Ethanol, a fuel made from corn, has long been a source of liquid fuel. But ethanol can also be a source of electricity to be used for batteries. The trick is making this battery more efficient. Through a process called Electro Oxidation, Dr. Jingyi Chen and her team at the University of Arkansas have created a chemical pathway that breaks carbon bonds to release more electrons and more efficiency.
So imagine that a crystal, you get a lot of atoms, right? And they organize in such a way, and then you make a surface of it. And then when a molecule comes in, it's also atoms. They will interact with the atoms on the surface of your crystal. So how they interact is based on how your atoms in your crystal organized. So, and then during the reaction, they will generate intermediate. This intermediate sometimes will poison the surface. So it's up to you to engineer, or up to us to engineer, how this surface looks like and what kind of atom, the composition of it. So then you can change the pathway, how this molecule change during the course of the reaction. So you can ultimately eliminate this poisoning species and make the reaction more efficient, go to the, from the reactant to the product.
Dr. Chen's process could enable the practical use of ethanol fuel cells as a high-energy, high-density source of electrical power, independent of the power grid. The result? Lightweight batteries that can power small vehicles and drones. But extracting electricity from ethanol is just one source of energy Dr. Chen's process can create.
Ethanol work is basically on the fuel cell and converted the chemical energy to electricity. We also, parallel with this, we have an NSF grant on electrolyzer, which we convert the electricity into chemical energy. For instance, we split water, use electricity to generate hydrogen in that case, which is a fuel.
Dr. Chen's research is supported by the Arkansas Research Alliance, because research matters.